electron withdrawing group sometimes can stabilize the system. For example, CN and CO. That means from where conjugation can occur. So maybe CN is very much electron withdrawing, but it is providing conjugation, right? Conjugation to the free radical. So this is the reason. I hope you have understood it. Thank you. Now we are starting the reactivity of free radical. Before till now, we have completed most of the basic things about structure, formation, and stability. And among the reactivity in the slide, let me take you on that slide where we have discussed the 6 dimensions by which we will be covering the uh, you know the reactivity. 1 minute. Yes. These are the 6 dimensions. These are the 6 dimensions: alkyl halide base, radical chain reaction, etc. So these are 6 dimensions by which we are going to cover the reactions of free radical. But before going to the free radical reactivity on that 6 dimension, two different kind of reactions occur in free radical now and they are very often. So let's discuss them first. So first reaction in this sequence comes with the name 1, coupling reaction. Coupling reaction. So the topic of today's discussion is coupling reaction, and second is disproportionation reaction. Disproportionation reaction. Disproportionation reaction. So coupling reaction and disproportionation reaction. Now what is coupling reaction? It is a very simple, but you maybe know the reaction, but you don't know the name. Which reaction is coupling, which is disproportionation. What happens? Suppose I have one CH3 dot and I have another CH3 dot. What will happen? They will couple. It is called a CC coupling because carbon is connecting to carbon. What happened? This like this. Our product is CH3 dot CH3 ethane. So this is our coupling reaction, simple coupling reaction. But what is disproportionation reaction? Suppose I have CH3 dot. Here both things should be radical, but here one is radical, one is neutral. Suppose H, CH2, CH3. That means ethane itself. So what will happen? This bond will break and connect to this hydrogen will break with free radical and connect to this carbon, and this will break like this. So from left hand segment we will getting CH3H, that means methane, plus we will be generating another free radical CH3 CH2 dot. So this is basically disproportionation reaction. But there are there is a, I would not say it exception, but there is a different kind of thing, different phenomenon occurs here. What is that? In 3 degree plus 3 degree plus 3 degree, when we will take two 3 degree free radical, then coupling reaction will not occur. For example, 3 degree means suppose 3 phenyl ring, phenyl dot plus phenyl dot. This will not generate, you know, phenyl. So this will not generate this kind of thing. Rather, why this will not generate? Because due to this steric hindrance of 3 phenyl ring, both the carbon will not able to come closer and couple. This is the reason. But rather, something else is going to form. What is that? Suppose my free radical, this free radical I am writing again. This free radical is nothing but this one, phenyl dot. Now what will happen? This radical will undergo resonance like this. Okay. After two resonating structure, you can draw by yourself what will going to form. This dot, double bond, phenyl. Now this thing is formed. Now this system can undergo again two type of reaction. In first way, another this phenyl ring, this can also convert in this way, and this can also give rise to another this kind of molecule. Double bond, yes, phenyl. and here dot. So this system if convert to this kind of resonating structure, then the product will be simple. This carbon and carbon will connect, and with that carbon we'll be having double bond, phenyl, phenyl, and here also phenyl, phenyl. Simple. But another possibility. Now in this form, the steric hindrance is reduced. So this can directly attack to this part. So here this can directly attack to phenyl, phenyl, phenyl. Dot. So what will be the product? Phenyl, 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 phenyl. Okay. Now the question is, what will be the actual product? First one or the second one? In the resonance energy class, in R bar trick, I have taught you this. If you have not watched it, link is in the description. Okay. So here phenyl, 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 4 phenyl ring. Here 5 phenyl ring. So here four benzenoid, 2 quinonoid. Here 5 benzenoid, 1 quinonoid. Now you can decide which will form. I will not tell you. Now you can decide. Okay. If you have watched this, you can definitely say which is going to be formed. Now, if another 3 degree plus 3 degree, if I take to clarify this concept more easily, then the example I would like to take is tert butyl. This one plus this one. This is also tert butyl. 1H. I am just writing in an open fashion. So what will happen here? This radical is going to couple with the hydrogen, and hydrogen, this bond will break in this fashion. So we will be getting one tert butyl system with one hydrogen plus one alkene, like this. So this will be the product. So this is basically the coupling reaction and disproportionation reaction. One homework for you. I am giving you you know, two free radicals, and with that they can perform both. Every radical always can perform coupling reaction and disproportionation reaction always, and we have seen its adverse effect on our body, on our human health in the previous discussion, in the previous lectures, right? With the title, the effect of free radical in human body. You can watch that. So with that, both the reactions are possible, disproportionation and coupling reaction. So with that, I'm giving you two radical, CH3 dot plus C2H5 dot. You have to tell you how many products are possible there. How many products will be possible? Options are 3, 4, 5, 6. These are the options. Okay. Will you do homework? But you will have a confusion that you have marked right or not, isn't it? So I will give it in a comment. Okay. So you try to comment down what will be the answer according to you, and I will clarify that. Within 1 or 2 days, I will reply there. Okay. Thank you.